Okay, so the next batch, these are going to be our logarithm equations. And I just think these are so much easier than those exponential equations. All right, so once you have one of the logarithms, the one that has the variable, once you have it isolated, we're going to exponentiate both sides to rewrite it in exponential form. All right, so I'm going to raise both sides, or I'm going to sneak in a 6. I'm going to exponentiate it by 6. That's what I call it. All right, this way my 6 and my log base 6 cancel out. So I'm just left with x minus 4. And then on the right-hand side, I'm left with 6 to the third. All right. If you'd rather, it's always just this base to this exponent is equal to this thing. All right. Spells out the same thing. All right. 6 to the third is equal to 216. And then use plus 4 on both sides. So x is equal to 220. All right. Number 7. It's going to be 3x to the second power is equal to 27. So it's going to be that whole 3x to the second power is equal to 27. Now, I could take the square root of both sides, but then I'd be taking the square root of 27. I don't want to do that. It'll be easier just to distribute this exponent. It's 3x times 3x, so that's going to be 9x squared is equal to 27. Divide by 9, and you'll get x squared is equal to 3, and then take the square root of both sides, and you're going to get x equals plus or minus root 3. But you can't have the minus version because your base of a logarithm always has to be positive. So you have to exclude the negative answer there. Number 8. So I want to get this logarithm that has my variable. I want to get it by itself. Luckily, log base 5 of 1 is just 0. Is that right? Yeah, this is just 0. All right, this part's a wash. It completely goes away. That's just 0. And then I'm going to divide by 2. Divide by 2. And so I have log base 3 of x is equal to 5 over 2. Now I guess I could have taken this 2 and put it back inside the parentheses as an exponent. It still would have played out the same way. All right, if I want to rewrite this in exponential form, I would do 3 as my base to this power is equal to this x. So it would be 3 to the 5 halves is equal to x. All right. Let me see what this comes out to. It's going to be some weird, nasty decimal. Yeah, 15.588. Okay. All right, number 9 here. Let's see what we can do with this one. They both have a log base 7 on both sides. So what I want to do is I want to get the log base 7 just alone by itself. So I'm going to put this 3 back inside as an exponent, and we'll have log base 7 of x minus 8 is equal to log base 7 of 2 to the third. Now, if I exponentiate this by 7, it's going to cancel out that log base 7. And that's going to leave me with x minus 8 is equal to 2 to the third, which is also equal to 8. Add 8 to both sides, and you get 16. That's our answer there. Okay, number 10, you've got 2 options. You could see what this comes to as a decimal, and then just subtract it from both sides so that you get this part by itself, and then you could exponentiate it. What I'm going to do instead is I'm going to condense it down to one logarithm. Because I've got the sum of 2 logs, I could group it together as the log of those two things multiplied. That becomes log of 3x. Okay. And then I could raise both sides. I could exponentiate both sides by 10. Okay. So that's going to give me 3x is equal to 10 to the second, which is 100. 3x is equal to 100. So x is equal to 100 divided by 3. Okay. Yeah, so what I was doing here on this one, because it was just a common log, my base was a 10, so I did 10 to this power is equal to 3x, right? I was doing that, writing it in exponential form. All right, number 11, it looks like everything is in log base 5. So let's go ahead and condense these two logarithms. It's going to be log base 5 of x minus 2 divided by 3. All right, because it's subtraction, my 3 here is going to go in the denominator. Is equal to log base 5 of 12. Exponentiate by 5 on both sides to cancel out the logs. And you just have x minus 2 over 3 is equal to 12. All right, multiply by 3 to cancel out the 3. You get x minus 2 is equal to 36. And then plus 2 on both sides. So x is equal to 38. Last one? Yep, number 12, last one. All right, this one, we'll go ahead and condense these two logs. So they're being added in the first place. So when I put them together, it's going to be the multiplication of those two. So log base 2 of, actually, let me change the color up. Log base 2 of x minus 3 times x minus 8 is equal to log base 2 of 14. So if I exponentiated by 2, it would cancel out my 2's, and I would just have this stuff is equal to 14. All right, and I'm going to go ahead and multiply out the x minus 3, x minus 8. It's going to give me x squared for x times x minus 8x, and then minus 3x, and then plus 24 is equal to 14. All right, to solve the quadratic, we're going to move our 14 to the other side and combine these terms right here. So that'll be x squared minus 11x plus 10 is equal to 0. We can solve it by factoring. All right, two numbers that multiply to 10 and add together to 11. That's 1 and 10. The factors, they both need to have a minus sign. So my solutions would be x is equal to positive 1 and x is equal to positive 10. Those would be my two answers. But 1 will not work out. Okay, if you did 1 minus 8, you'd have negative 7 in here. And you can't take log base 2 of negative 7. So this one right here, this is a false solution. This is extraneous. All right, but there's nothing wrong with x equals 10. All right, you can do 10 minus 3 and get positive 7. You can do 10 minus 8 and get positive 2. So this solution is valid. It's not a bad answer at all.